As Blaise Pascal once said, "The heart has its reasons which reason knows nothing of." And indeed, his life and contributions to the world are a testament to that. Born in Clermont, France on June 19, 1623, Pascal was the third child and only son of Etienne Pascal. His mother tragically passed away when he was but 3 years old. In 1632, the Pascal family relocated to Paris. Here, the stage was set for young Pascal's unconventional education. Etienne Pascal, Blaise's father, held unorthodox views about education. He decided to take charge of his son's learning himself. Etienne believed that Blaise should not study mathematics until he was 15 years old, and to ensure this he removed all mathematical texts from their home. But as they say, curiosity killed the cat. But satisfaction brought it back. Blaise's curiosity was piqued. At the age of 12, he started delving into the world of geometry all on his own. His dedication and explorative spirit led him to a significant discovery, that the sum of the angles of a triangle are 2 right angles. When his father found out about this, he was impressed and conceded, allowing Blaise access to a copy of Euclid. By the time he was 14, Pascal began accompanying his father to the meetings of Mersenne, a religious order frequented by various intellectuals of the time. It was here that Pascal was introduced to the work of Desargues, which he soon came to admire. At the tender age of 16, Pascal presented a single piece of paper to one of Mersenne's meetings. This paper contained numerous theorems of projective geometry, including what is now known as Pascal's mystic hexagon. Thus, at a tender age, Pascal had already started making his mark in the world of mathematics. Pascal's fascination with geometry did not end with his early discoveries. As a young boy at the age of 14, he found himself in the company of great minds at Mersenne's meetings. These gatherings were frequented by renowned scholars like Gassendi, Roberval, Carcavie, Ozout, Midorge, Milon, and Desargues. Among them, Desargues, a fellow Frenchman and an architect, caught Pascal's admiration. Desargues' work on perspective and projective geometry resonated with Pascal's inherent curiosity. As Pascal's understanding of geometry deepened, he began to contribute his own original thoughts to the field. The turning point came when he was just 16. In June of 1639, Pascal presented a single sheet of paper at one of Mersenne's meetings. This wasn't just any piece of paper, mind you. It contained several theorems of projective geometry, showcasing the young Pascal's brilliance. One of his most notable contributions was the theorem of the mystic hexagon, now famously known as Pascal's theorem. This theorem states that if a hexagon is inscribed in a conic section, the 3 intersections of opposite sides will lie on a straight line called the Pascal line of the hexagon. This theorem, though seemingly simple, is a cornerstone of projective geometry and has far-reaching implications. Pascal's work on the mystic hexagon was a significant leap forward in the understanding of projective geometry. It was a testament to his natural talent for mathematics and his ability to see patterns and connections that others couldn't. At just 16, Pascal was already leaving his footprints in the sands of mathematical history. His contribution to geometry was not just about the theorems he introduced. It was about a young mind's relentless curiosity, a passion for understanding the world, and the courage to challenge established ideas. It was about the spirit of discovery, the same spirit that continues to drive mathematical exploration today. Pascal's brilliance was not confined to theoretical mathematics alone. He was also an accomplished inventor, and his most notable creation was the first ever digital calculator known as the Pascaline. This ingenious device was born out of a practical need to assist his father in his work as a tax collector. Inventive as he was, Pascal was just a teenager when he embarked on this project. He spent 3 painstaking years, from 1642 to 1645, perfecting this groundbreaking invention. The Pascaline bore a striking resemblance to the mechanical calculators of the 1940s, a testament to Pascal's forward-thinking design. Yet the path to creation was not smooth. Pascal faced significant technical challenges due to the design of the French currency at the time. Unlike today's decimal-based system, the French livre was divided into 20 sols, each further divided into 12 deniers. This meant that Pascal had to deal with a division of 240, a far cry from the simpler division of 100 that we're used to today. Despite these complexities, Pascal demonstrated remarkable problem-solving skills. He tackled the technical challenges head-on and managed to incorporate this convoluted currency system into the design of the Pascaline. The calculator could perform addition and subtraction directly and multiplication and division through repeated addition or subtraction. However, despite Pascal's ingenuity and the revolutionary nature of his invention, the Pascaline was not a commercial success. By 1652, only 50 prototypes had been produced, and very few machines were sold. The production of Pascal's arithmetical calculator ceased that same year. Despite the commercial failure of the Pascaline, Pascal's invention was a testament to his ingenious problem-solving skills. His work on the calculator laid the groundwork for future developments in mechanical computing, proving once again that Pascal was not just a mathematician, but a visionary inventor who was ahead of his time. Pascal's life took a significant turn in 1646. In that year, a series of events would shape the course of Pascal's life and work, including a personal tragedy that sparked a profound religious awakening. His father suffered an accident and injured his leg, leaving him bedridden and in need of care. This care came in the form of two young brothers from a religious movement just outside of Rouen. Their influence had a profound effect on Pascal, leading him to a deep exploration of his own faith. This spiritual awakening was not a quiet, introspective affair. Instead, it ignited a burning curiosity within Pascal, a curiosity about the natural world and its relationship with the divine. This curiosity would fuel one of his most iconic series of experiments. Around the same time as his religious awakening, Pascal began to delve into the mysteries of atmospheric pressure. He was fascinated by the invisible forces that hold our world together, and he sought to understand them better. Using a simple barometer, he started to measure the pressure of the atmosphere and how it changes at different altitudes. Pascal's experiments were methodical and meticulous. He observed how the mercury in his barometer fell as he ascended a mountain and rose as he descended, providing the first experimental evidence that the weight of the air decreases with height. His experiments with atmospheric pressure not only shaped our understanding of the physical world, but they also marked a significant shift in scientific methodology. Pascal was one of the first to insist that scientific theories should be based on experiments that anyone could reproduce, not just on abstract reasoning or philosophical principles. Pascal's religious awakening and his experiments on atmospheric pressure may seem like two separate paths, but for Pascal they were intertwined. His faith fueled his scientific curiosity, and his scientific discoveries deepened his faith. They marked a new phase in his life and career, one where he pursued truth in both the spiritual and the physical realms with equal fervor. Pascal's religious awakening and his experiments on atmospheric pressure marked a new phase in his life and career. Blaise Pascal's contributions to the world extend beyond his lifetime, a truth that is as evident as the principles he uncovered. His life, though short, was packed with groundbreaking revelations that have shaped our understanding of the world. Pascal was a mathematician, but his work has left a lasting mark on various fields. His contributions to geometry, notably projective geometry and conic sections, are still fundamental in the field. His mystic hexagram theorem, presented at a tender age of 16, remains a significant part of the study of projective geometry. Then there's Pascal's influence on probability theory. In correspondence with Fermat, Pascal laid the groundwork for a new mathematical discipline that has since become indispensable in numerous fields. From statistics to economics, from computer science to quantum physics, the theory of probability underpins our understanding of uncertainty and risk. But Pascal's genius wasn't confined to the realm of mathematics. He was also an inventor, an innovator. His Pascaline, the first digital calculator, was a marvel of its time. It was a testament to Pascal's inventive spirit and his ability to apply mathematical principles practically. The Pascaline may not have been a commercial success in its time, but it paved the way for the calculators and computers we rely on today. And let's not forget Pascal's philosophical insights. His religious awakening led to profound reflections on faith, reason, and the human condition, recorded in his unfinished masterpiece, The Pensées. His exploration of the paradoxes of existence continues to captivate philosophers and theologians alike. Above all, Pascal's life and work embody a profound curiosity and a relentless pursuit of knowledge. He was a man who encompassed the universe with his thought, who pushed the boundaries of what was known in his time, and whose legacy continues to inspire us. Indeed, Pascal's genius continues to resonate, reminding us that through space the universe encompasses and swallows me up like a dot. Through thought I encompass the universe.